I'm Joe Miketta, the Warning Coordination Meteorologist here at the National Weather Service Forecast Office in Mount Holly, New Jersey. And the purpose of this brief presentation is to discuss the changes that will be taking place in our winter weather program this year. The map that you see on the left below is an example of a snowfall total map issued by this office. It's obviously one of our most popular products during the winter season. In order to generate this map, the forecaster analyzes various meteorological parameters and models and uses information from this analysis to come up with snowfall totals that he or she believes best describes the upcoming event. There's uncertainty in every snowfall forecast because the amount of snow that eventually accumulates on the ground depends on a lot of factors, such as the temperature profile, the dew point temperature profile, moisture and temperature advection, wind speed and wind direction, not only at the surface but higher up in the atmosphere as well. While these deterministic snowfall maps represent the forecaster's best judgment, these maps can't possibly explain all the uncertainty in the forecast. So, in order to provide the end user with a better understanding of this uncertainty, we will be issuing 3 probabilistic snowfall total products beginning on December 1st. The first product is shown on this slide. Using statistical analysis on over 57 computer models, including the European model, we will provide a potential minimum and a potential maximum snowfall total map for each and every snowfall event this year. And this will be in addition to the deterministic forecast, or the most likely forecast, that we've been developing up to this point. The picture on the left represents the minimum amount of snow that can reasonably be expected from the upcoming storm, and the map on the right represents the maximum amount of snow that can reasonably be expected from the storm. I say reasonably since there's still a 10% chance that even less snow could fall than represented on the map on the left, and a 10% chance that even more snow could fall than represented in the map on the right. It is important to note that both these maps will be updated twice a day around 5 a.m. and 5 p.m. and will no longer be published once the snow actually begins to fall. At that point in time, the map in the middle, the deterministic forecast generated by the forecaster, will be the only snowfall forecast available. This most likely map actually gets generated 72 hours out. So whenever we expect snow, day 1, day 2, day 3, this forecast map in the middle will be generated along with the minimum and maximum potential maps until the snow starts to fall. Now, why are we doing this? The potential minimum and the potential maximum snowfall maps that I just talked about provide the endposts for goalposts for snowfall possibilities. Using this goalpost, people will be able to make informed decisions to minimize negative impacts from the storm, because now you will have a reasonable estimate of the limits associated with the upcoming snowfall event. You'll no longer be left guessing as to how much snow could possibly fall from this storm or how little could fall from it. Those values will now be provided to you in these maps. Now, let's take a look at an idealized situation where we have an upcoming snowfall event. And the black line that you see at the top represents the right goalpost. It's the potential maximum amount of snow from the upcoming event, and the gray line at the bottom represents the potential minimum amount of snow that can be expected from the upcoming event. And 3 days out, at the beginning of this example, you can see that the goalposts are pretty wide apart. As we get closer to the event, as one would expect, the goalposts should get closer together. For a couple different reasons. Number one, the models are hopefully starting to hone in on one or two particular solutions. But another reason is that as we get closer to the event, the human forecaster can actually add value to the forecast and make it better. So as we get even closer to the event and we start issuing our most likely forecast, our deterministic forecast, that deterministic forecast issued by the National Weather Service forecaster will lie somewhere between the goalposts, somewhere between the potential maximum and the potential minimum. Now, there's no guarantee. In fact, it's very likely that the deterministic forecast developed by the forecaster will sometimes be closer either to the minimum or to the maximum. That's to be expected, but it will always remain somewhere in between. And there could also be some oscillation, and that happens all the time. As we get more information and as the picture becomes a little more clear to us, we'll make some adjustments to our deterministic forecast. And sometimes that's higher than the previous forecast, and sometimes it's lower than the previous forecast. Then, once the snow begins to fall, the goalposts go away. There is no longer a potential maximum and potential minimum map generated by the National Weather Service. It will just be the deterministic forecast developed by the forecaster. And that will continue and be updated as often as needed until the snow ends. Now, in addition to the potential minimum and potential maximum snowfall amounts and the deterministic forecast generated by the forecaster, we will also provide exceedance graphics. And on this current slide, you'll see a whole bunch of small maps at the top. And basically what they give you is the probability of having greater than a trace, greater than 1 inch of snow, greater than 2 inches of snow, greater than 4, greater than 8, greater than 12, greater than 18 inches of snow. So when you take the mouse and move it over the greater than 8 inches of snow in this example, that map is enlarged in the bottom left so you can actually see it. And the numbers represent the possibility of exceeding 8 inches of snow. So in other words, I see the number 6 over Philadelphia. That means that there's a 6% chance of snowfall total exceeding 8 inches of Philadelphia from this event. If I go up into the southern Poconos, there's a 10% chance of exceeding 8 inches of snow. And if I go down to southern Delaware, there's a 2% chance of exceeding 8 inches of snow. In addition to all the products talked about so far, we will also be issuing a table of probabilistic snowfall accumulation. What we do is we list numerous locations across our forecast territory, and we provide you what the potential minimum is, what the likely amount is of snowfall from that event, and what the maximum potential maximum amount of snow might be from the upcoming event. And then we also give you the percent probability of different snowfall values or ranges at that location. So in this case, basically there's an 11% chance of having no snow, a 7% chance of having between 1 and 2 inches of snow, a 50% chance of having 4 to 8 inches of snow, and basically a 0% chance of greater than 12 inches of snow. Now, if none of these locations meet your fancy, you can also type in the name of the county that you're interested in, and a list of locations within that county will pop up containing the same information that's listed here. I've used Bucks County as an example. I typed in Bucks County, and you can kind of see for these 4 locations, Bristol, Morrisville, Percy, and Quakertown, all the information contained in the larger city list is contained here. Now, one of the suggestions that we've already had for Bucks County is that we add a few more towns, including the town of Doylestown, since that's the county seat, and since it's centrally located in Bucks County. So that might be one of the things that we can make a change to. And we can add more towns. So we'll see how this experiment unfolds, and if we need to add more towns based on user feedback, we will do so. Let's take a look at a recent example. We had a snowstorm the day before Thanksgiving, and the map in the middle is the deterministic forecast developed by the forecasters here at the forecast office. And the map on the left is the potential minimum map that was generated for that event, and the map on the right is the potential maximum map that was generated for the event. You can kind of see that the forecaster was forecasting 10 to 14 inches up here in the higher elevations of Carbon, Monroe, and Sussex County, New Jersey, and basically around an inch or so, maybe a little bit less, on the coastal plain of New Jersey, Delaware, Maryland. If we take a look at the potential minimum map, we're basically forecasting 0 as a potential minimum for the coastal plain. And looking at the potential maximum, computer programs were actually forecasting over 15 inches in the higher elevations. If we take a look at what actually happened, we can see that there was basically nothing on the coastal plain of New Jersey and along the Delmarva, which matched very well with what the potential minimum map was showing. And we had a little bit over 15 inches in the higher elevations of northwest New Jersey and the southern Poconos, which is really basically what the potential maximum map was showing. So both these maps provided a good estimate of the goalpost, if you will, of this event. But I will say that the forecaster didn't do such a bad job either. 10 to 14 inches of snow in the higher elevations is actually a very good forecast. We had a few reports of up to 15 inches, which was captured by the potential maximum map. The forecaster did a pretty good job forecasting the higher amounts of higher elevations. So all in all, for the event the day before Thanksgiving, all three of these maps did a pretty good job of indicating what was going to happen. Okay, in summary, along with the traditional most likely snowfall total map generated by the forecaster, the National Weather Service will also issue snow forecasts that include a range of snowfall possibilities for every winter storm this winter. To do this, 3 new products will be issued: the potential minimum, the most likely and potential maximum maps, the chance of exceedance maps, and the probabilistic snowfall accumulation tables. These 3 new products will be updated twice a day, around 5 a.m. and 5 p.m. They will stop being issued once the snow starts to fall, at which time the deterministic forecast from the forecaster will take over, and that forecast will be updated as frequently as needed. These new snowfall probability products are considered experimental, which means they may not always be available if unforeseen problems arise, computer problems, telecommunication problems, etc. We're hoping that doesn't happen. We're working on ways for that not to happen, but until we get all the glitches worked out, we can't guarantee that the product will always be available, although we're going to strive to have that happen. These new snowfall probability products will only be issued for the Northeast Corridor in the northeastern part of the United States, obviously, which is served by the National Weather Service forecast offices in Boston, New York, Philadelphia, and Washington. These new products will not be issued for ice accumulation. They will only be issued for snow storms, not ice storms. All of our winter weather products, including these new probability products, will be available on our winter weather webpage at www.weather.gov/phi/winter. Comments are always welcome. There's several locations on our winter weather website that I just mentioned where you can click and leave comments. One location is on the snow accumulation potential maps, and you can just click on leave feedback, and your comments will be forwarded to the appropriate people to comment on. If you'd like to have or leave a comment about this presentation or about any of the products I talked about in general, I would be happy to answer them. My contact information is listed on the screen there. Best way to do it is send me an email, because then if I can't provide you an answer, I can forward the email on to some of my colleagues who might have more information than I do. I appreciate your time watching this video, and hopefully these products will be of some use to you this coming winter season.